Hey YouTube, welcome back to my data structures and Typescript series. In this video, we're going to go over the implementation for the circular buffer. If you need an introduction to the data structure, then I have a previous video. You should check that out. I'll have a link in the description below for the playlist. And I'll also have some more links that link to the source code for this code if you need a reference. It'll be on GitHub. So this class, circular buffer, is going to take a generic type t, and then it's going to use that for the first instance variable, which is a list. And then since it's fixed size, and when we read elements, we're only advancing pointers and not actually deleting raw elements, we have to keep track of the size variable. And then capacity is going to be the maximum capacity that we use. And then our two pointers, which you see in the previous video, are read index and write index. And then we also need an equals function that the client needs to provide if the generic type t cannot be used with the triple equal sign comparator in JavaScript. So the constructor is pretty easy. We're taking in the capacity and equals function and then initializing the variables. So we're creating a new list with the new array with capacity, and then we're creating our size, setting the size to 0, this dot capacity, setting that to capacity, and our write and read and write index are starting at 0. And then if they do supply an equals function, we're going to set this to the equals function. And you know what? I think I want to do something like this, and then I'll set equals function in this constructor. So I'll say equals function equals function if they provided it, or utils dot default equals. Great. So going on to the first set of methods, we have niceties, which I call them. The first method is the size method, which returns the size of the circular buffer, not q. And this is in constant time operation because all we do is return this dot size. Nice and easy. Is empty just returns this dot size equals 0. It returns a boolean, true if the buffer is empty and false otherwise. And clear deletes all elements in the buffer, and it takes the runtime is O of capacity. The reason why it takes the runtime is O of capacity is because we have to set this dot list, and we're going to create a new array with this dot capacity. So when we initialize arrays, it's going to take that amount of time to initialize it. And then we'll also set this dot size equals 0. So this is why we are keeping track of the capacity when the client first provides it to us in the constructor, is because when we clear the array, instead of setting this dot, let's say like this dot list dot length equals 0, which is like a JavaScript trick you can do, we're going to create a new array because then we don't want to reinitialize re-expand the list array back to this capacity length. So we're going to just create a whole new array, instantiate that, which takes O capacity time. So the next two methods we have are insertion and deletion, enqueue and dequeue. And enqueue enqueues element into the queue, which is a constant time operation, and it takes an element variable parameter, which is a type t generic, and doesn't return anything. So what it's first going to do is going to take this dot list, and we're going to access this dot write index, and we're going to set it to element. And then we need to check to see if we have overwritten any values, and if so, we need to advance our read pointer, because if the previous example, let's say we insert 1, 2, and 3, and then now our write pointer is now pointing at 1 again. If we have, and then let's say we haven't read anything, so the read is pointing at 1 as well. If we overwrite this with 4, then we want our read to actually point to 2, because 2 was the next element that has the longest time waiting in this queue, in this buffer, because it's first in, first out. So we're going to have to check to see if we have overwritten anything. So we're going to do that by checking to see, we'll do a boolean, and the boolean will say is this const element is overwritten, and this is going to be this dot size does not equal 0, and this dot write index is equal to this dot read index. So the second branch of this Boolean variable should be self-explanatory. We're checking to see if the write index is equal to the read index, and the first half of the logical AND operator, this dot size is not equal 0. Make sure that we're not dealing with an empty list, because if you remember up above, the read and write index both point to 0 at first. So if the element is being overwritten, then we need to advance our read pointer. So we're going to do this dot read index is equal to this dot read index plus 1, and then the first time you'll see this as the modulo operator, mod this dot capacity. And the reason why we need to apply the modulo operator is because this could potentially be outside of the array. So taking the value of this and modding it by the total capacity allows us to wrap around, get that wraparound logic if the read index is past the capacity. And if it's not, then it'll still stay in bounds. And then finally, we can increment our write index the same way we increment our read index, which is adding 1 to it and then taking the modulus of it with the total capacity. And then finally, we'll just increment this dot size. And that's the enqueue operation. So the dequeue method dequeues an element from the queue, and it returns a type T generic or null in case there was no element in the circular buffer to begin with. So if this dot is empty, then I'm going to return null because there's nothing to return. So then let's save the removed value in a variable so we can return it later. And the way we do this is access the element at the read index, right? Because the read index is the whole reason for that existing is so we can access the element that's reading. And then we want to increment the read index for the next time dequeue gets called. So again, we use our modulus trick. This dot read index equals this dot read index plus 1. And then we take the modulus of this with the total maximum capacity of the array. And then we're going to decrement the size variable by 1. And then we'll finally return the removed value for the client. And that's the dequeue method. So the next two methods are methods that access the elements from the circular buffer. The first one is peeking the front, which peeks the element at the front of the buffer, and this runs in constant time. And it returns a type T generic or null, depending if there's anything in the circular buffer. So if the circular buffer is empty, then we're going to return null. Otherwise, we will return the element that is at the read index, because that is at the front of the circular buffer. But we're not going to we're not going to move any pointers forward because we're just peeking at it. So we're going to return this dot list at this dot read index, which is the first one about to be popped off. So this next method is peek back, which peeks the element at the back of the buffer, and this also runs in constant time and has the same return type as peek front. And what we have to do is return the element that's one spot behind the right index, because the right index is pointing at the spot we're about to write. So the last element that we just put in the circular buffer is the element before right index. So again, we'll check to see if this is empty first, and if it is, then we're going to return null. Otherwise, we're going to take a, let's say, const I, and set that to this dot right index minus 1, because we want to, whoops, it's not a method, it's a property. We want to have I point to the element before right index. But if right index is at 0, that means this should actually wrap around backwards. So then we have to check if I is less than 0. Then we'll set it to the last element of the circular buffer. So we'll set this I equals dot capacity minus 1. And then we're going to return set this to a variable that we can mutate. And then we're going to return this dot list at I. And that's peek back. So again, we're doing this check to check to see if the last element that we need to peek is the last element. And that means we have to wrap around I. So the last method is the contains method, and this is under searching. And this takes in a parameter called element, which is a type T generic, and returns a Boolean true or false to see if the element is indeed in our circular buffer. So we're going to leverage a built-in JavaScript method called array.prototype.sum. So the way it works is if we call this.list and we have access to the sum method, it's going to take in a callback function and it's going to run it for every value in the array, and the callback function is going to return a Boolean, and if it returns true for one of them, then the whole sum method is going to return true. So we're going to get a value t, which is going to be each of the values in our list array. And the function that we want to apply to each value is this dot equals function, and then value, and then element. So this is just using the function that the client has passed in, and just to see if any of the values in the list is equal to the element. And that's in linear time because we have to walk through the entire list array. So there you have it. That was the circular buffer data structure, the implementation for it. And I'll have, again, the code below in the description below. I have a open source repository that you can use for reference if you want to implement these data structures yourself. And you don't often see circular buffers. It's one of the data structures that are not often seen, but I thought I would include it because it has some cool, I guess, paradigms to wrap your head around. No pun. You see it more often in lower level code, but nonetheless, I thought that I would just include it because, I don't know, circular buffers are pretty cool. So yeah, that was it. I hope you enjoyed, and I'll see you in the next video where we'll talk about priority queues and binary heaps. See you then.